Pierre C. Hohenberg is a French-American theoretical physicist, who works primarily on statistical mechanics. Hohenberg studied at Harvard, where he earned his bachelor's degree in 1956, his master's degree in 1958, and his doctorate in 1962. Afterwards he was from 1960 to 1963 at the Institute for Physical Problems in Moscow and at the École Normale Supérieure in Paris. From 1964 to 1995 he was at Bell Laboratories in Murray Hill. There from 1985 to 1989 as director of the Department of Theoretical Physics, and there from 1989 to 1995 as distinguished member of technical staff. At the same time he was from 1974 to 1977 professor for theoretical physics at the TU München, where he was already in 1972-1973 guest professor. From 1995 to 2003 he was Deputy Provost of Science and Technology at Yale University. Since then he is at Yale, Eugene Higgins Adjunct Professor of Physics and Applied Physics. Hohenberg was additionally from 1963-1964 and again in 1988 guest professor in Paris and 1990-1991 as Lawrence Professor in Leiden. In 2004 he became Senior Vice Provost of Research at New York University. Hohenberg is also politically active. In 1983 he chairman of the Committee of the APS for the Freedom of Scientists, and in 1992-1993 on an APS committee for the support of scientists in the former Soviet Union. From 1984 to 1996 he was on the Committee for Human Rights of the New York Academy of Sciences. Hohenberg is a member of the American Academy of Arts and Sciences, the National Academy of Sciences, and the New York Academy of Sciences. He received in 1990 the Fritz London Prize, in 1999 the Max Planck Medal, and in 2003 the Lars Onsager Prize of the APS. Hohenberg formulated in 1964 with Walter Kohn the Hohenberg-Kohn theorem in the course of his work on density functional theory. He became famous primarily for his investigations in the 1960s and 1970s in the theory of more dynamic critical phenomena close to phase transitions. He collaborated thereby with Bertrand Halperin and Xiangkheng Ma in the application of renormalization methods. Additionally, Hohenberg worked on hydrodynamic instabilities and on pattern formation in non-equilibrium systems. Independently of Merman and Wagner, he proved in 1967 the impossibility of spontaneous symmetry breaking in 1 and 2 dimensions. An accomplished continuous distance swimmer, Hohenberg in the second decade of the 21st century annually contests the artist-writer Richard Castellanets in a 1-hour race at the NYU Coles Pool. Usually they declare a draw. Selected works: P. Hohenberg and W. Kohn. In Homogeneous Electron Gas. Phys. Rev. 136 B864 B871. B.I. Halperin and P. C. Hohenberg. Generalization of scaling laws to dynamical properties of a system near its critical point. Physical Review Letters 19, 1967. 700, DOI 10.1103, Phys Revlet 19.700, B.I. Halperin and P. C. Hohenberg. Scaling Laws for Dynamic or Critical Phenomena. Physical Review Volume 177, 1969. 952, DOI 10.1103, Phys Rev 177.952. B.I. Halperin, C. Hohenberg, Xiangkheng Ma. Calculation of dynamical critical properties using Wilson's expansion methods. Physical Review Letters Volume 29, 1972. 1548, DOI 10.1103, Phys Revlet 29.1548. J. Swift. C. Hohenberg. Hydrodynamic fluctuations at the convective instability. Physical Review, A. Volume 15, 1977. 319, DOI 10.1103, Fezriva 15.319, PC. Hohenberg. Existence of long-range order in 1 and 2 dimensions. Physical Review Volume 158, 1967. 383, DOI 10.1103, Fezriva 158.383, PC. Hohenberg. Dynamical Theory of Critical Phenomena, in E. G. D. Cohen, Statistical Mechanics at the Turn of the Decade, Descartes, New York 1971, PC. Hohenberg. I. Halperin. Theory of Dynamic or Critical Phenomena, Reviews of Modern Physics, Volume 49, 1977, pp. 435 to 479, DOI 10.1103, Rev Mod Phys 49.435, MC. Cross. C. Hohenberg. Pattern Formation Out of Equilibrium, Reviews of Modern Physics, Volume 65, 1993, pp. 851-1112, DOI 10.1103, Rev Mod Phys 65.851.